Alright, so in this example problem we have a sample of helium that is in a sealed container where the pressure is initially 30,000 pascals and a volume of 0.01 meters cubed. And the temperature is 30 degrees Celsius. The volume and the pressure of the gas are then doubled, and we want to know what the new temperature is and what the mass of the gas container is. Alright, so the ideal gas law, pressure, volume, and temperature, they're all what we call state variables. And so we can take a state relationship and divide it by a state relationship in order to be able to compare two different states. So I've taken the ideal gas law and divided it by the ideal gas law. And what I've done here is I've written the final conditions in terms of the initial conditions. So we know that the pressure and the volume of the gas are doubled. So that means that V2 is going to equal 2 times V1, and that P2 is going to equal 2 times P1. Because it's a sealed container, that tells you that N2 equals N1. I'd have to mention if there's a leak in the container and you're losing gas molecules. And we're asked what happens to the temperature. So we want to know what T2 is. So I've replaced V2 with 2 times V1, and P2 with 2 times P1, and since N1 equals N2, these cancel out and the ideal gas law cancels out. So we're left with this relationship here where I can now cancel out P1 and V1, so we're left with 2 times 2, which is 4, and therefore T2 is 4 times T1. So I can take my initial temperature, convert it to Kelvin, because remember you have to be in Kelvin in this relationship, and then multiply it by 4 to get the final temperature. Now for part B, we want to know what the mass of the gas in the container is. So we can use the ideal gas law to go from the number of moles to the mass by using the molar mass. So I have looked up the molar mass of helium, which is 4 grams per mole, and then I divided by 1,000 to convert it to kilograms per mole. So this is what the value you see here is. Now we need to find the number of moles. And I'm going to use the ideal gas law in order to do that. Now we canceled out here because it's the same in state 1 and state 2. So as long as I use P1, V1, and T1, or P2, V2, T2, I should get the same number of moles because that value does not change from state 1 to state 2. So it looks like I chose to use state 1, where the pressure was this, the volume was that, and the temperature is this, because I'm taking this number and adding 273 to convert to Kelvin. And I probably did that because those values are just stated in the problem. Otherwise I'd have to go through here and double this, and then use this temperature down here. But either way, you should get approximately the same number with a little bit of difference, probably due to different rounding errors.